So what I wanted to do now is to show you the kind of systems, embedded systems that my lab has built, just to give you a flavor of our capabilities. And some of these systems are built by my graduate students who are teaching assistants in this class. Maybe I should use this chance to introduce the four excellent TAs. And so starting from the maybe my left, Xu Hengbai, please stand up and take a bow. Uh, and then second one next to him, Gao Zhongyi. And then third one, Chen Yilin. And fourth one, Zheng Huaming. Yeah, thank you. And so yeah, these students are quite good and have built some of these systems I'm about to show you. Okay, so it's like, wow, a lot of systems. Yes, we built a lot of systems. I've been building real systems since 2003. And some of these systems are actually still in use, not just by us, but by people at other institutions. So these can be divided into like the miniature. WSN stands for wireless sensor node or sensor network. Okay, we've been building a new one maybe once every year or every 2 years. And then also, so these, I'll show you some of these in a minute, but the miniature sensor nodes, they are something this size or even smaller. And there's one that's really, really small, 8 millimeters. And then there's another category of boards for what's called structural health monitoring. So these are really larger systems that are meant to go inside buildings, structures like bridges, tunnels, and all that. And so they are larger, more powerful, and also we built one for Yitri, which is Gong Yan Yuan. They're just 15 minutes from here, and we built a whole what's called smart container for them in the past year, and we're doing the second phase now. I'll tell you a little bit about that too. The third category of systems that is built by my lab is called energy harvesters. These are embedded systems that will harvest energy from like solar, so like solar panel, you probably know, right? From sun. You use solar panel to convert to electricity, or from a windmill, or from something. And some will collect from another very low power source. And then we built a bunch of medical devices also. So some can do cancer detection. Others are for like monitoring babies and adults and for all sorts of things. Okay, so I'll show you the first one called EcoNode, and this one I think it was the first wireless sensor node that was 1 cubic centimeter, complete with battery, antenna, everything. Weighs 2 grams, and so yeah, this was very small. And in fact, we still have these in our lab, and there are still users of this node even after like 8 years. And it's small, compact, and it can do motion sensing. And this is compared to another node from Berkeley. We're 1/10 their size. Um, and and so this is a close-up look at the EcoNode. So it uses a system on chip. It's that on the left, that black box there you see. That is the microcontroller with integrated radio. And then the silver box above it, that's what's called a triaxial accelerometer. it can measure acceleration. And then below it, that longer white thing with the dark circle or the dark square, that's a light sensor. And the blue stick that with the word ring sun on it, that's an antenna. That's a chip antenna. And then if you flip it over, that has the program memory and oscillator and the power switch. Okay. And if you put it on the scale, well, it's 0.6 grams with a battery, 1.2 grams. So battery is twice the weight as the board itself. And it has expansion capabilities for digital, analog, power connections. And you can connect it to multiple peripheral devices, including like a speaker, a camera, and many other things. Okay, and so that was first generation. Second generation is actually a predecessor to the Bluetooth one that we'll be using. And now there's a larger node and a smaller node because the larger one is more convenient for prototyping. The smaller node, well, it's convenient for wearing or embedding inside something else. And it's a newer generation chip, better accelerometer and all that. Okay. And then the same overall chip, but then the smaller size was built. This is the same size as an SD card. You might know from using digital cameras. And this also was the first one to add like a magnetic switch, so that you don't have to turn on and off by hand. This you can put a magnet next to it and can turn it on and off. So that's nicer, especially if you have to put it inside like a watertight enclosure. So make it waterproof. And this is closer to the one we'll be giving you. The one we'll be handing out. Well, actually, it could be this one, or it could be the latest one that's being built right now. We're testing that. And it's called Eagle BT. BT stands for Bluetooth. Actually, T is for TI, but so it's Bluetooth 4.0. And so there again, two versions of this. The larger one on the back, you can put a micro SD card on there. The micro SD card shown up there, and micro SD card is already pretty small. And we have a mini version that's 8mm by 8mm. So if you know how small micro SD card is, you look at 8mm. So I have a real sample here. It's this small. You can almost swallow it, but I haven't asked any of my students to swallow one yet. And so it's really tiny, but it's basically the same sensor, same chip as the one on the left, and that one is this one. And it's the same chip, same accelerometer actually. So it can do motion sensing. You can connect with a smartphone. It also has USB on there. So it's like, wow, okay, that's pretty powerful. So that it was first built in 2012, and we've been making improvements in the past year. And we are building one with a lower power version of the chip. And we got already the early samples, and they've been testing okay, right? Yeah, say yes. Yeah, okay. So yeah, so I think you'll be able to use some of these. And so what features do these have? Well, so memory, there, like the bigger one, you can put in. It has an onboard flash, so you don't have to put in the extra one. It's standard, so it's 2 megabytes of serial flash. And then there's expansion port for USB, micro SD. They use the same accelerometer, so you can sense acceleration. And what can you do with an accelerometer? I'll show you some videos in a little bit. And they're the same microcontroller. They run the same Bluetooth 4.0 stack. They have 12-bit ADC, also on-chip voltage comparator. And how you will use some of these, we'll tell you later in the course, and so forth. Okay. So yeah, so that's the close-up view of the small EcoBT node. So it's really small. I think we set the world record here, but there could be a even smaller one. Just depends on if we get to that. I think the chip, this one is using a 6mm by 6mm chip, but I think there is a new one that's 5 by 5mm from CSR. You can try that one. Okay, and you can connect these directly to a smartphone like iPhone 4S and up, or Android 4.3. You don't have to go through an adapter or dongle or anything. And you can also connect to what's called like a gateway device, kind of like your access point. And so there's one that is used in our lab and in another research lab based on what's called a Panda board. Some of you may have seen it or may not. Basically, it runs Linux. It's a 32-bit ARM core, and it's essentially a single-board computer. And it also supports Bluetooth 4. And this one was designed last year. Well, this one does have an ARM core, and it also supports Bluetooth 4, but only as a slave, not as a master. And otherwise, these features are mostly the same as EcoBT. It's harder for us to get enough of this chip because this is a newer chip. So maybe we have to wait longer